All right, peeps. So, okay, there we go. Let's do volume washers. Okay. Let me try to make a sketch here. Here's my x-axis. Here's my y-axis. And let's have a curve here. And let's have a curve here. And I'm not going to call them anything on purpose right now. Let's say I'm rotating about the x-axis. So if I'm rotating about the x-axis, then everything has to be with, wow. Did I really just call that the x-axis? Y-axis. It's been a long day. Okay, everything has to be with respect to y, and we think with respect to y, we think right minus left. So the way I know that this is a washer, this is my solid, right? So I have to do horizontal strips. And as you see, for all of my horizontal strips, those green lines, there's a gap. And as long as there's a gap anywhere, then it's automatically a washer by default. What I mean is there's a gap between this green line and my axis of rotation. I mean, maybe there's no gap right here, but that doesn't matter. There's still a gap over here. So our cross sections are going to be circles, but with a hole in it. So the formula is we have big R, which are our outer radius squared minus our inner radius squared. And I'm going to call, and the way you know who's big R and who's little r is your big radius, big R is going to be the distance from the one that's furthest away of these two curves. Who's furthest away from the y-axis, the red curve or the blue curve? So this distance here. Okay, so that's your big R. So I'll call this big R. And then the one that's closest is this red curve. And if I subtract this blue distance with this red distance, I'm left with the green distance. So I'll call this little r. All right. And of course, that is with respect to y. I don't want to go into too much detail because I think I'll lose you if I start getting super specific. So this is when I'm rotating about the y-axis or a vertical line. Right? So in this specific scenario, you know, if I think right minus left, well, big R minus 0 is just big R. And then over here, little r minus 0 is just little r. So that's r squared. Now if I were to change this doodle, and let's say I'm not going to rotate it about the y-axis anymore. I'm going to give these little names here. And let's say I'm rotating about this vertical line here. Okay. You can see that there's still a gap between my horizontal strips for my solid and this green vertical line. So that's how I know that it is a washer. Now, in this case, who's furthest away, my blue function or my red function from this green vertical line? The red function. So then the distance, so I'm going to call this, so this distance here is r, big R. And then this, let me change colors here. Uh-oh. And then this little distance between the blue function and the green line, that's little r. And so that would change the game then. So I would do, if I want this horizontal distance for big R is going to be right minus left, where I'm subtracting this axis of rotation, this equation, with my red function. And then for little r, my inner radius, I'm going to be subtracting, I do right minus left, my vertical line equation, this green line, minus the equation for this blue function right here. And that would represent little r. Okay. Now, let's say if I were to do volume, let me scroll down, extend this page. All right, so if I were to do volume and washer, and this is with around, and I'm rotating about the x-axis or a horizontal line, then the formula is pretty much the same, except my limits of integration, everything's with respect to x, and that's going to be big R squared minus little r squared dx, whereas the other one's with respect to y. Did I write it with respect to y? Yes, I did. I'm not crazy. Only sometimes crazy. So if I draw a function here, and I'm rotating about the x-axis, everything has to be in terms of x, so I got to do vertical distances. So you see these vertical distances here, these green strips, there's a gap. So that's how I know it's a washer between the green strips and this x-axis. And we do, so big R is going to be the distance between the function that's furthest away and the function that's furthest away. When I compare the red and the blue with the x-axis, the blue function is R. This, I'm measuring this vertical distance, which ends up being, R minus, big R minus 0, because that's the equation of the x-axis. And then my red function's distance to the x-axis, I call that little r. And again, I'd be subtracting the red function minus 0, because that's the equation of the x-axis. So that's how we get that equation. Now, if I was rotating about a horizontal line, okay, let's put a line over here, and then this is the x-axis right here. You could still see that there's a gap between the green strips and this purple line that I'm rotating about. But since this is horizontal like the x-axis, everything's with respect to x, and big R is now measured by this total distance from the blue function to the purple line. So I would do top minus bottom, so big R would be this distance here. So blue function minus purple line equation. And then little r would be the distance between my red function and the purple line. That would be that distance squared. That's it.